This talk is entitled C++ Core Guidelines. I'm Peter Sommerlad. Most of you might have seen or heard from me. I'm usually the one who argues with the other presenters about their bugs and mistakes in their codes on the slides and stuff like that. It's just by training I teach too many students and have to review too much code of them, so I just cannot hold back my horses. I excuse myself for that. But bad code is something I care about, and one thing is I want to get rid of bad code. I cannot shoot all the bad programmers, so the only thing is I try to write better tools and educate them better so we get less bad code. And the C++ Core Guidelines is one attempt led by Bjarne Strostrup and Herb Sutter and many more people from Microsoft and others on the world to actually provide help for the uninitiated C++ programmer to write better code. And I will give you a glimpse of the core guidelines, and you will see in a moment why it can just be a glimpse in 90 minutes. And I will show you another tool, not Visual Studio, that also has some core guidelines checks. We are working on them, so it's not done, not finished. You might find inaccuracies, but we try hard to provide not only checks for the guidelines, but also fixes that allow you to see what's going on. And all these fixes are interactive. So if the fix is doing something that you don't like, it's a Control-Z away to get back. Now we are filling up. So grab your chocolate. I think now you have the chance, if the seat next to you is empty, grab the other chocolate as well. And you might have recognized this nice hat. And why do I wear sometimes this hat? I'm not Swiss, but I live in Switzerland now for more than 20 years. And I'm a Swiss delegate for the C++ Standardization Committee. And I hosted it twice at that nice campus. And I will host 99% or 95% sure, next year in June, again, the C++ meeting. So whenever you wondered what the C++ committee does and you haven't been to Switzerland recently, come to us next year in summer and join the committee and have a look. You're invited as a guest. If you come regularly, you need to be a member of your national standardization body in the Brits will tell you if you're British, and the other countries you have to figure out yourself. Ask Roger Orr, for example. He will be definitely someone who knows how to get to the standard committee if you're British. Now, if you take a look at the core guidelines, and if I can activate one thing that happened to me, I just downloaded it as a PDF, and I was wondering, why is it called core? A core is something in the core, the essence, and we have 377 pages, at least as rendered on my browser when I generate the PDF. So that's really, really big. On the other hand, if you look at what are guidelines actually doing, and I still cannot figure out, there might be several things. You might feel like a duck on a leash if you have to follow guidelines. Anybody using programming guidelines in their job? Who is happy with them? Who is happy with them and hasn't defined them on his own or her own? The goal of the core guidelines is more on what's on the left-hand side, the Autobahn, where you have a clear path and then just zap through. But sometimes they might feel like being in the kettle in this fence there in the coral. So guidelines can have two-edged sword, and I will give my criticism of the core guidelines as they stand today or when I prepared the slides, so some things might have changed in between, so don't put the finger on things that I misinterpreted because they changed underneath, because it's a work in progress. It's not finished. The goal is actually to help people the transition from, let's say, C++ code as it might be still written today, but was the way to write C++ in the 1990s, towards modern C++ style. And the modern style, I'm not only talking about modern C++ as written down by Alexandrescu in 2000 and others who explained to us how templates actually work. I have to confess, when I first read the modern C++ book by Alexandrescu, after page around 200, I just had to give up. So, but now with the core guidelines, and especially with the improved things in the language from 11 on, many things get simpler to write and easier to use. The problem is not everybody is aware of that. So some of the guidelines actually specify how to check for violations, which is a good thing. If you can easily detect the violation and even provide a recipe on how to get rid of the violation and improve your code, that's a good thing. And we take a look at the philosophy. The main thing is, the bad thing is you might get pink elephants from your code because of the defined, undefined behavior. There are people working in the standard to reduce the amount of undefined behavior as specified in the standard, but nevertheless, undefined behavior is a curse and, how do you say that, a blessing. It's both. It allows compilers to generate more efficient code and optimizers to even more aggressively optimize your code. But it also digs a lot of traps for us to step into as a programmer, especially because it just might work today. And it might no longer work tomorrow with a different optimization setting or with a different compiler or a new version of a compiler. So that's one thing. So one philosophy of the core guidelines is not get into the pink elephant trap. By the way, who knows where that comes from, that pink elephant? Any Belgium here? Yeah. So it's a beer brand. So I stole that, but I took the picture myself, as you can see. And some of the things is where the core guidelines are a little bit, let's say, stepping beyond what's currently available in the standard, and to provide for the gaps in the standard or things that are not yet standardized, they also provide a guideline support library, which is open source, cross-compiler, available, but at least requires C++ 11, but I believe maybe even 14 right now. And it provides stuff that we might have already in the 17th standard or might get with the 17th standard when it's officially blessed by ISO, and some things we don't have there yet. And other things might be proposed under a different name and slightly different functionality, like RAII will not be called finally in the next, hopefully, standard, unless the library evolution working group changes the name again. The good thing about the guideline support library, it's header only, so it's easy to wrap and use, so no binary compilation and compiler flags to deal with. It's just compiled with your code. Anybody has seen this picture in one of my talks before? Very few, very few. So actually, what does it say? It's a traffic sign. So it's not that the philosophy of the core guidelines is actually new. I'm teaching things like that for several years now, like don't write your special member functions yourself and don't use new and delete directly in your code. For new and delete, for example, you have make unique or make shared, and the delete will be taken care of yourself. Even destructors I consider harmful. If you in your own classes require explicit resource management, you're either writing library components or you're doing something wrong. Because we now have in the standard library at least unique pointer to keep track of dynamic resources. And if you're not writing an RAII class, don't write your own destructor. Only there do it. And also assignment operators. Rely on what the compiler generates from you and write your classes in a way that the compiler generated special member functions just work. Other things, don't write your own loops. One can argue, well, we have range 4 now and everything is nice. But very often the loops that you write have been already programmed for you and are part of the standard library. The bad thing is many books on teaching C++ only have the standard library algorithms in chapter 20 and later. There's one exception, which is accelerated C++, which is now also no longer that new, but I start with algorithms in lecture 2. Not 1, because there I have to explain how to start the compiler. But in lesson 2, when I teach C++, the first thing is algorithms. And if you're not using them regularly, do some code katanas and try just to replace your loops by algorithms. Another thing that I care about is unit testing. I know there are thousands or hundreds of C++ unit testing frameworks. You might have the statistics. We bundle one that is Swiss quality, cute, it's header only, simple, and tries to be simple. And that's what I want to say about my past. If you might find some videos of my talks, previous talks, and at least some slide sets going into details of each of these things. Now, let's see. The good thing is always to start with an example. And I picked 2 very random examples in this section on expressions and statements. And the nice thing about the guidelines is they are numbered, so it's easy to refer to them. The bad thing is they are numbered, so you never know what number meets which guideline. So one thing that I already talked about is prefer the standard libraries over other libraries or handcrafted code. And that's actually use an algorithm like accumulate instead of writing loops like that. So for loops summing up things, 4 lines, accumulate, even saying what it is, begin, end, and 0. This is a version of the future using ranges, which are not standardized yet completely, so it's not part of the language yet, and the standard library implementations, except if you go for the ranges, TS, and implementations. But at least this single line explains much better what actually happens, accumulate, where you have to look at exactly, oh, is the index right? Is it this thing right? Is the index and the addition always correct? Do you have overflows there, which might happen with the accumulate as well?
Is the less than really less than equal?
Yeah. So range 4 helps a little with that. It gets rid of that problem, but still you have to figure out what's happening in the loop body, and it might be a little bit more involved like that. And that's another thing I picked randomly is always end a non-empty case with a break. So, or provide a fall through, which is explained in this comment or attribute, which is explained in these little dots where I just removed the text to fit it on the slide. And that's something that an IDE can easily check, because we can do some flow analysis and look for branches, and if every branch is actually ended with a break. And in that code, that's real code from, I believe, Fish Shell. Yes, Fish Shell is my example. And it says, okay, problem, no break at end of case, add break statement, or add a suppressing comment. So that's exactly what's in the guideline, set in the guideline, and the tool would actually do that for you, so you don't have to type it. And she's taking notes about features he wants to build. I do the same when she is talking, so no problem. Because all leads to better code. That's my goal in the end. So, what's cool about the guidelines? They foster modern C++ style. You get safer code, less undefined behavior, better no undefined behavior. That's a guideline, but getting there might be tricky. You get pointer safety, and my stake is no plain pointers at all, but we're not there yet. You get rules about parameter passing, not using globals. Who's using global variables? Writable ones? I know. Well, this guy over there implements a standard library, so there's in the standard global variables like C in, C out. So.
I don't really have a choice.
It fosters good software engineering principles. So a lot of the core guidance is not only about C++, but actually about good software engineering. Less verbosity, so less code equals more software. Who said that? I will tell you in a moment. Just a riddle. A lot of common sense. And there's a nice book by, I believe Stephen is his first name, Stephen Dewhurst, on C++ common knowledge. And the problem is with common sense, it's very often it's not that common. And a lot of 1990 C++ is still written and exists, and a lot of Cisms are still there. Just don't do it. Don't return a plain pointer that you might have allocated in your function and tell the world, well, do something with it. And maybe not telling them to actually free or delete it afterwards. And you don't have to do that. It provides guidelines for transformation, so how to get from old code to newer code. The problem is all these transformations are hidden in the 300 pages of rules, so it's hard to follow them all. And we have the potential for static analysis because many rules actually tell us how to enforce them or how to check for violation. The negative things, and that list is not complete, but at least gives you some impression. It's not about making the bad things about the core guidelines, but it's too many rules. You can't know them all. With some rules, they are redundant or very similar. And also, sometimes it seems to me that some people at Microsoft looked at their code bases, and every strange construct they found, they put in as a core guideline violation, which is something one might discuss. And also some rules only provide bad examples, not how to do it better, which is also a tough thing. And there is overlap, I already said that. The categorization is not always clear because we have these overall generalized rules, and then some specific rule might fit into several categories. The common sense is also something that's a problem. And some specialist rules are some that might not actually be useful for the average programmer. Like things how to write your destructor. If I teach you not needing to write a destructor, why would you need to learn how to write a destructor? Unless you're implementing a library class where you actually should know how to write a destructor before you start out. Or doing move operations correctly, syntactically. Some rules are very modern, like use concepts. Who's using a compiler supporting concepts for production code? Well, 2. But you both are very, very close to the standard. So that's the majority might not be able to use a compiler doing concepts, and it's not done yet. It's not standardized yet. Concept, so that's something. Some helpers from the helper library might become slightly different in a different name, or might be even language features like contracts, not concepts. And one thing I claim for migration, I will explain shortly in more detail. The core guidelines actually provide a migration path from code using pointers, plain pointers for resource management, towards, let's say, more modern style. And one, I would say, scaffolding for that, for migration, is a type called owner T, which is used for pointers that you manage yourself in your code, and where you mark the pointer, okay, I will take care of any resources held by this type or this variable, and will get rid of them afterwards in the end. And if you migrate code using pointers freely, plain pointers, you might have pointers that refer to a resource that they don't own, and you might have exactly the same type of pointers that own the code. And if you migrate module by module or function by function, you might still have pointers for non-owning and owning as plain pointers, and you will only be able to mark the owning pointers with owner and not the other way around, so you don't know which code you actually touched and had a look at. And I won't show it today, but I had one group of students working on these ownership things, and they actually added another type borrower for those who are non-owning users of the pointers. Sorry, Bluetooth 4 is too eager to turn off the connection. That's it. Yeah. Now, the philosophy of the guidelines is the important thing. Express ideas directly in code and so on. And the main thing, as I said, is get rid of undefined behavior. So how do we express ideas directly in code? There are many things in detail, but one thing, comments are not code. If your code requires comments to be understood, it's not the comments that have a problem, or the non-existing ones, it's a code. So name functions accordingly, or types or variables, so that you tell actually what they are for and what they are doing. If you write inline comments to explain stuff, that's an indication that your code requires refactoring and separation of things, so it's easier to understand. Very often I see inline comments in code that I review, where actually the inline comment is the name of the function of the a few lines that come afterwards. And if you have, let's say, functions that go vertical, who has seen functions with more than 20 lines recently? Okay. Most of them require refactoring. In the 1980s, I was teaching C, and then the guideline was the function has to fit on the 8025 screen. And that's still true. And maybe even shorter now. Because we have more expressive language in C++, we don't need that much. Another thing is, if you have things like velocities, distances, time, don't use numbers for them. C++ has a great advantage that you can wrap them in a dedicated type, specifying the unit, and then compute with them safely so you don't add, let's say, meters and seconds, which doesn't make sense. Things like that happen from that, and there are plenty of examples where mixing units, and I'm not calling about US and UK gallons, which is also a very interesting fact I wasn't aware of, being grown up in a metric country, but use units. And there have been several talks about units in the past at ACCU, at CPPCon, so you might find the videos there. And that's just one thing. Another thing is express ideas directly in code. Call the algorithm, for example, finding an element in a sequence instead of writing your own loop. Come on. Why do they create a Bluetooth thing when it doesn't work? Write ISO standard C++. And one thing compilers care for their, that's the interesting thing, it buffers. Okay, here we are back now. Compilers care for their users, so they are quite user-friendly in accepting non-standard code by either providing extensions or just doing interesting thing because they might be buggy. And I shouldn't do too much Microsoft bashing, but the Microsoft compiler, anybody has used Visual C++ 6 in the past? Still using it? Oh, lucky, a few poor guys there, which was horrendously interesting when you tried to write template code and other things, and the preprocessor, last time I looked a couple of years ago, had bugs the C preprocessor had in 1985. Still does. Yeah. And so GCC, on the other hand, is guilty of providing generous extensions that might not work on other compilers. Use multiple compilers. I say Clang and GCC because they are now available on all platforms, but better use another one if you can get hold of it. And compile maybe on Linux and on Windows your code if you really care about portability and longevity of code. And the one thing, the code that works will have to work much, much longer than you ever thought it might. Just one example. In 1997, when I moved to Switzerland, one of my first customers there that I served wanted a tool that should work just for the year 2K, because then they would replace the system, but they wouldn't be sure if they would be by January 1st. So we wrote a piece of software for replacing a hardware that should go away anyway. That software, which should run 2 years about, or maybe 3, is still in operation and used. And the good thing is it's called hack. Which stands for something internally there, but it wasn't a hack, and we nevertheless worked with test automation and C++, and it's still in operation and works. And that's just one example. Just consider all the COBOL system around, who should have gone away in 2000, but never did. Okay. Let's see. Express intent. It's very similar to express ideas directly in code, so you might ask, what's the problem? One thing is use a range for loop if you actually iterate over all elements. Don't use while with a variable that's declared outside. And the important thing that I need to teach over and over is know the standard library and the language. I have reviewed dozens of different, let's say, providers of source code, not only students, many companies as well, where people declare a variable as a vector and then write a loop for initializing the vector, and 3 lines later, take another vector and copy the elements into that vector with a loop, with one-off error sometimes. And it just would be just initialize the variable correctly in one place by using the iterator initializer. And things like that easily reduce the size tenfold in small local contexts. So Kevlin, Henny, and also I do always say something, a term that I learned first here at ACCU, decremental development. Get rid of needless code. And my goal is actually to reduce code size to 10%. Not by 10%, to 10%. It's hard, but at least it's a goal to strive for. Type safety. Who's programming in JavaScript? A few. JavaScript has a very interesting type system and no type safety. Perl comes close and is even more interesting in syntax and concepts. But C++ fortunately has a static type system that's interesting. And since C++ 11 with auto and type deduction, it's really, really useful now because you don't have to spell out all the interesting types. You just write auto and get the right thing deduced by the compiler. And most of the time also by the IDE. So when you hover over auto, you will actually see the type that's deduced for it. Don't use unions. Who's using unions? Oh. There's SCD variant soon, or boost variant now to use instead. Casts. My stance is almost every cast in user-level code is a design problem because either the wrong type was used, the same concept was represented with different types, or you have other problems in your code. And there are very, very few exceptions where casts are actually necessary, and those belong in libraries and low-level code, and you don't want to use that everywhere. The problem is one of the first things people learn, oh, you have this thing, or come from C where you have to cast almost everything because every interface is defined with void pointers, so when you want to use it, you have to cast your void pointer to what you believe is behind it. Who's not doing casts in C? Okay. And being trained from C, it's very hard to get rid of that habit, especially since the C-style casts actually do bad things to your code because they might have interesting effects that you don't want. Another curse we inherited from C is the array decay to pointers when you pass them as a function argument. And the big problem is you have to pass the size separately or guess what the size is. And guessing always means it can be wrong, and passing it as a separate argument might mean you might pass the wrong argument there. Or you might not even know from the 5 arguments where 3 are ints and 2 are pointers, which belongs to which when you call it. Yeah?
What do you suggest if you have a vector of, let's say, ints? Those are numbers, the grades maybe of students, and you want to calculate an average. So you actually accumulate and you divide by the size of the vector. You can have overflow. Do you then suggest don't use ints, go to the highest type?
Well, you can use accumulate with the double as a starting value, and then you won't get an overflow. So.
But be sure that the double really is a double. If it's a literal, then it's 0.0. Otherwise,
Yeah. But if you have scores like that, you might consider having a type for representing scores that actually deals with the overflow correctly. You see? Where was it? Express ideas directly in code, use the units. And you can use units for your own code. For the narrowing part, we now have the curly braces who prevent you to initialize a variable with the wrong type or with a too big value. For dynamic things, the GSL, the support library of the core guidelines, provides narrow cast on narrow, who might produce a runtime error, or at least mark your code. This is a narrowing conversion. I'm sure it will serve work, and if it doesn't work, I'm fine with it. So things like initializing I with the floating point constant is not compiling. That's a good thing. And other things, yeah, I told about. Oh, come on. Everything that can be checked at compile time should be checked at compile time and not at runtime. The slides will be made available, so if you're not taking a video or tweeting right now, it's no need to take photos. They will become available soon when I figure out how to upload them to Dropbox of the ACCU. Who's using W error as a compiler option? who's not using that? Who's using static analysis tools like the Visual Lint or PC Lint or whatever? Many things. There are plenty of them, and it's good to use them because not all cover all areas of the language or all corners of your code. Who's using static assert? Okay, you're all perfect. So I don't have to teach you a lot about static assert, but things like assumptions in code, like is my pointer as big as an int? Which might be wrong today. It was true for many, many years. I came from an era where it wasn't true always. And with 64-bit things, you might still have 32-bit ints or other way around, depending on your compiler and platform settings on some interesting platforms. And there, it might no longer be true. So check at compile time. Use a type system. If you cannot check it at compile time, check it at runtime. There's also philosophy of the core guidelines. And it should be checkable at runtime, and especially array pointer decay is not checkable at runtime because you don't know what size the array originally had. So what's supposed is actually passing either std arrays, by reference for example, or use span from the core guideline support library, which we might get in the standard in the future. Also for multi-dimensional arrays, hopefully. Someone is thinking about how to implement it.
Someone is unconvinced of the necessity.
Okay. The people might use Chapel then, those who need it. Okay, we might get contracts. There is some support for contracts in the GSL. Yeah, I'm not using contracts that much because a lot of contracts I use are actually encoded into unit tests where you can see what the contract of a component are. And the big thing is very conscious and error and exception handling, and I can give a lecture for another 90 minutes on how to do that in C++, what options you have, and what to look out for, and things like that. Now I have to watch for the time. If you have runtime errors, catch them early, and better don't produce blue screens or interesting dialog boxes with hex numbers for your users. Again, that's not perfectly described. It just says, okay, do something, and it's not very instructive on how to do that. Some things you might do using @member function of vector or an array instead of the index operators. But if you're concerned about speed, you might not want that. But if you write code where you use and index operators, you might consider using a corresponding algorithm instead. It's rarely that you have to access elements individually by index unless you stride, but there, again, for strides and stuff like that, there are iterator adapters that provide interesting mechanisms. You got a question?
I don't have a question, I have a comment.
Okay.
And this might sound like a pitch for a talk of mine, a little bit. But mostly what I want to say is if you're doing something with a collection or a range and none of the standard algorithms do what you want, you should seriously consider writing your own algorithm. Because then you can put that in your toolbox and reuse it. And you can write tests for it and be confident that it does exactly what you want, rather than writing a handle loop every time.
And especially writing that loop hidden in a function that is 100 lines longer. Thank you, Marshall. Just can say, yes, please. Go to his talk next year.
It's on YouTube from CPPCon last year.
Okay, you have it already. So watch his talk then. The problem is, for me, I don't have the lifetime left for all the videos I might need to watch to learn. That's a problem I have with videos. But we get one as well, so hi, Fox, looking at it afterwards. Let's see. Don't leak any resources. That's the most important character in the C++ language is that one. And I lost my clicker.
Doesn't work anyway.
Okay, most of you folks will know what RAI stands for, and unique pointer is actually a blessing for a lot of cases, and also shared pointer and make shared. We have the scope guards for locks. We might get in 2020 scope guards for general things if my proposal gets through. Everybody wants it, but everybody wants it by a different name. And that's the interesting thing. If you propose something that everybody knows about, it's hard to get it right so that it's actually right for everybody. But stay tuned, we will get it, and the core guideline support library provides it by a different name. The biggest thing is no naked owning pointers. So if you take one thing home and have pointers in your code that actually hold onto resources that you have to release at some point in time, get rid of that code, refactor your code to put them either in a unique pointer or some other RAI wrapper so you don't forget to handle ownership. Another thing, there's actually no need for calling new, delete, malloc, free, fopen, strut up, and things like that. And there was a question.
Yes, there's a question. What about virtual clone functions that are supposed to with polymorphic classes, which are supposed to return to the pointer of the derived class, and due to covariant return type, they need to this cannot be embedded in a smart pointer. This has to be a real pointer.
Wrap it in concept-based polymorphism. Wrap it in a concept-based polymorphism wrapper.
I'm sorry. The language. The question was about cloning, and I didn't get what the problem is.
You have an abstract class which to allow creating copies of it has a clone function. This is
Yeah.
a clone function which each of the UI classes
Has to implement.
return not the pointer to the base class, but to specific subclass, UI class.
The problem is that smart pointer doesn't support covariant.
Yes.
And why do you return the derived class pointer and not just the shared pointer to the base class?
Because you want to avoid slicing and some of the other problems.
If you're passing a pointer around, you can have a slicing. It's only when you pass the object around.
Yeah. That's why I say return a shared pointer from that clone function or a unique pointer even of the base class, but then you have the base class with the virtual destructor and everything should be fine. So I don't understand the problem. Maybe that's something to look at in the concrete code base to see what the problem actually is. I can't get my head around it. And if you have other things, use vector, strings, arrays, std arrays, not arrays, instead of pointers. Don't waste time and space. And for me, that includes space for source code. I'm not talking about white space in your source code, but don't write needless code, especially don't write your own loops if you have algorithms for doing so. And if you write your own loop because there is no suitable algorithm, extract it as Marshall told you. And use a standard library. Don't invent needlessly your own data structures. And as of this morning, don't use tuple and pair without the real need. Because it's easy to define your own struct holding several things together and give them appropriate names. Instead of writing get one and you figure out what that one actually means. If you're starting doing macros for that one to describe what the field is, consider writing a struct instead and name the field that way. Immutable and mutable data. Use const. Who can claim that his or her code is const clean?
I don't know what you mean by const clean, so
Everything that mustn't change is actually defined const.
yeah, see, I don't declare local variables as const where I probably should.
And I can show you, we have a tool that actually will mark those things and tell you, okay, control 1, change it and add const. So it's detectable, maybe not perfect, that's why it's interactive, not globally, but you can actually get rid of these non-const things where they should be const.
It's also a speed issue, not just a correction issue. Like if you look at code gen on .bolt of things which didn't have const or did have const in some trivial spot, the optimizer does way, way better just because you mark it const.
Sometimes, yes.
Sometimes, and not all the time.
Well, const is a good thing is because it's much easier to reason about code when things don't change. And the default should be the opposite around, which is in some languages, and where you have the regular thing is everything is immutable after initialization, and then you have to say if you want to have something mutable. And with lambdas, we get that in the language as well, because there the stuff is immutable. And if you have a parameter that's passed by value or by some type, it's not a problem to define that const, because that const only is for the body of the function, not for the signature of the function. So there's no danger in defining that const, because it doesn't change the signature. That's something people might not know. If you have a const reference and const pointers, that's something different from a non-const reference and a non-const pointer. But if you pass an int and declare or define, when you define the function, write int const, that's not a problem. It's still the same function. And also, immutable data is thread safe. And you cannot have immutable data that is not initialized, which is also a corner of undefined behavior in some cases. And nevertheless, we're doing C++, so there will be messy constructs. And if you have them, wrap them, maybe even in a library, or at least in pieces where you can separately test for them. So any portability issues are localized and not spread throughout your code base. And there is this thing called less code, more software. So get rid of needless code, refactor your code, make it simpler and smaller. And some things we have in our IDEs, and C-line as well, extract function refactorings, type and template aliases with using, which are much nicer to read and understand, especially if they're complicated. And things like extract template parameter for generalizing code, where you might want to get rid of a concrete type, and maybe more ideas. And we've seen some meta-programming talks by some other people around. Now, I told you I don't have time for the 377 pages, just some things that I found important. There are some myths about C++, and fortunately the core guidelines try to bust those myths, like all declarations on top of function. There might be coding guidelines telling you to do so, because the author might have come from Pascal. Who has learned Pascal at? Yeah. There you needed to do it, and that's the way to do it. It was needed in C, and I'm not sure if it's still needed in C. No longer. But it was in C, and the best when I was teaching C in the 1980s, the best thing I was working as a trainer, and there was a former or still COBOL programmer. The first thing he did was defining about a dozen variables of different types, A1, A2, A3, and B1, and so on, just in case he might need them. Don't. There's another rule that makes bad code structure sometimes, or actually forces people to use goto, is a single return rule. Who has that in poor guys. If your function is so long that you cannot see all the returns at one glimpse on your screen, 8025, then your function is too long and has other problems than the single return statement. No exceptions. Who is not allowed to use exceptions? Okay. I still believe that rule is wrong in most cases where it's applied and enforced. But I understand the situations where it comes from, where there might be runtime overhead from just supporting exceptions. On the other hand, all the scaffolding required to do error handling instead when you don't have exceptions could be much more, and non-compiler generated code that can be much wronger than what the compiler actually generates. But that's my personal opinion, and it might not be universally applicable. One class per source file, it's also something that's not necessary. We don't program in Java. And even they cheat with inner classes. Two-phase initialization, doing two-phase initialization still. Init methods. That hurts. Hurts. Don't do it. The constructor is the way to initialize an object, and if it's not possible to initialize it, fail by throwing an exception.
Tell that to Qt.
What's that?
Tell that to Qt.
Qt is good, but it has a design of the mid-90s, and it still has, even though they support more modern language features.
Unfortunately, they got a new hire who hopefully will help them out.
Yeah, but you won't port all user code, and it's a framework, so you all, let's say, frameworks are a curse because you inherit from framework classes, and you might get divorced, so marriage is something you might terminate. You can't get rid of your genes, at least not in our universe yet, or on our planet yet. Maybe for small bacteria you might be able to do that, not for humans. Go to exit for error processing. Who is doing that? That's a single return. Are you one of the single return guys?
Well, I inherited that code base.
Yeah, get rid of it.
How about go to fail?
What's that? It's called throw. Resource leaks, concrete guides, solutions, smart pointers, RAII classes, either do it DIY or use it, and the ownership marking, which I believe is kind of a temporary thing in the core guidelines. It's like a scaffolding for migrating code to better places. I still don't, there are examples where it says, okay, I have an owner of a T-star and I initialize it with new. If you code like that, don't. Use a unique pointer and make unique, or a shared pointer and make shared if it's actually shared. Arrays, std array and std vector are the array classes of C++. And that's it. No plain arrays. And we have even checks for that and some refactorings to get around that. No pointer arithmetic, and that's also something that shouldn't be done. And we don't have a check yet, but I think Klangtidy is marking those things. Ownership. The core guidelines tell you, okay, if you have a raw pointer, this means you refer to an object that might exist or might not exist, but you're not caring about its lifetime. It's guaranteed that it's alive while you're using it, and you don't have to clean up afterwards. So my stand is use references wherever you can, and only use pointers where you might have no such thing. For code-based migration, we even have that, like the owner thing, we have a borrower to just mark these things to show, okay, I considered this pointer, and this is definitely not an owner. That's a question.
Can I suggest STD or boost optional of the reference?
That's on my next slide or somewhere down. So if you have things, if you want to return something where you might have no value to return, and you don't have a type that actually provides an extra value for nothing, like pointers do with null pointer, then use optional. And we have std optional, or will have std optional, and there's boost optional as a replacement in between.
Even as an input argument, something which is optional?
Could be, yes. Don't pass pointers around freely. Use references, and if there is something that might not be there, optional is the key. No plain memory management, and the marking of owning pointers is kind of migration path, but not the final stop. Wrap them in a RII wrapper. And we might have more pointer refactorings. We have some things like detecting C strings and replacing C arrays with std array and things like that. I might show you depending on the time. You might run out of that. The owner thing, I already talked to you with that, and go to my lightning talk for the rest of that slide tonight. Come to the lightning talks. A lot of things about interfaces, like make them explicit, no global variables, no singletons. Who is using singletons that are not whiskey? Refactor away from them. I have one of my, I also teach patterns and frameworks, and one lecture is called flyweight boxing and killing singletons. Because they are global variables in disguise. And the only thing where they came from was dynamic initialization of global data, of global objects, let's say like that you couldn't be sure that they would be initialized in the right sequence order, which is still true in C++ cross-compilation units. Destruction, I don't talk about destructing a singleton or replacing a singleton. There's plenty of literature around how to get rid of singletons, and if you believe they are a good thing, they aren't. Just write unit tests for your code that use singletons or global variables. What's that?
You can wrap a singleton in a traits class so that if you specialize in traits, it's marked array. Get around that.
You can cheat. Still, it doesn't make your code better.
Then you have object lifetimes that are not stack-based. What are you going to do?
There's main.
Yeah.
What else? Precise and strongly typed interfaces, no void pointers and stuff like that. Pre and post conditions, you can actually, with the GSL, you have expects and ensures and conditions, but without real language support, it might be hard to get the post conditions formulated well, because you need to memorize old values and stuff like that for comparisons. It says state template parameters with concepts. We don't have them universally yet. So take your time. And I think a big problem with concepts is that we don't have the overall experience of using them throughout. We live in a world with unconstrained templates and the detection idiom, thanks Marshall and thanks Walter. And that actually gives us a lot of leeway to provide more generic code even without knowing it up front. And concepts actually constrain that and might constrain that just a little bit too much in your using case. And I'm expecting interesting discussions about concepts in the next decade when they are available for everybody. And there will be the core concepts guidelines, I believe, after maybe at least 5 years of usage experience. Yeah, I am repeating myself. Function rules, plenty. Now, come on. Class hierarchies, like, what if I highlight? Oh, interesting things. Place helper functions in the same name. Oh, interesting. Place helper functions in the same namespace as the class they support. That's a very important thing. We have argument-dependent lookup. Who is not familiar with ADL, argument-dependent lookup? Oh, perfect. A few confessors. Learn it. If you program in C++, ADL is important to understand because you might get interesting consequences of not knowing it, especially if you're reusing names from some others. Minimize the exposure of members, make them private, but don't provide getters and setters. Every getter-setter pair in a code base is usually a code smell of wrong encapsulation. Oh, you have a comment on that?
Oh, I was just going to say a setter it says, please break my invariance.
Exactly. And you should strive for immutability anyway, so setters are a bad idea. Things like constructors, assignments, destructors, or special member functions, and we have some implementations around those. Even though you shouldn't write them yourself, you might have them in your code base. Like things like, oh, a destructor should be no except. It's by default, but it's better you say so explicitly. And the default constructor should also be no except, and who has been bitten by an unintended conversion constructor application, make your constructors explicit, and we have a check for that, so you can get it on a key press without typing explicit.
Sorry, what's the rationale for always making constructors no except?
What's?
No.
Default constructors, well, there are some, let's say the general guideline should be default construction should just work. If your constructor requires an external resource that might fail to be available, then it should throw, because you cannot guarantee your invariant. But let's say if you have a class with a trivially available invariant, then the default constructor should guarantee that will not throw.
Yeah, okay, yeah.
There are exceptions, like, oh, I want to allocate that port on that GPU or I/O board, and it might fail spuriously, then it's not no except. But for user-level code, a default construction should just work or not be available. Yeah?
Could be hard, but the moment you have a number which is a vector or a string, you can have that allocation from the right.
If you have that, that's a bigger problem than then you get an exception. So it fails. A bad alloc is usually you're in a very bad place anyway. So most of the thing you can do is terminate anyway. So it's. if it's empty, the string and vector, it will not fail because it will not allocate usually.
That's the default constructor.
Yeah. If your default constructor acquires big resources, they might need some arguments to be initialized, so it's no longer default constructor. A lot on class operations. You see where these 377 pages come from. A lot on resource management. Naming and layout, that's something I care about. Don't say in comments what can be clearly stated in code. And for me, it's don't write comments. If your code requires comments, you're doing it wrong. Keep comments crisp. I would say keep them empty. I know it's a very extreme position. I always set the flag very far for my students to actually run fast. They might never reach it, but at least when they get 20 kilometers instead of the marathon, they will get somewhere. And you've got a question.
No, not really. I agree with your sentiment on comments, with one exception, and that is your code says what and how, but it never says why. Why, you can say in a comment. If you have a construction that is non-obvious, but it is non-obvious for a reason, explain the reason.
But that might go in architectural documentation somewhere else.
Sure.
Unless it's a very local thing because, okay, we have, but very often you can even say that with a good name. But
if you can, that is correct, yes.
it's, and the thing is, only the code tells the truth, because that's what actually the compiler compiles. And the comments aren't compiled, they're just ignored. Indentation is no longer a problem. IDEs provide that for you. But I learned that there are so many different styles you might want to mimic yesterday, so that's something where you should at least follow some common style. Don't use Hungarian notation. Who is using P something or C something for marking pointers and consts? Poor guys. I know Microsoft is guilty of that, and it's very bad. Because you just might change your type to be now a unique pointer. So do you now change your P to a UP everywhere? Well, we got rename refactorings that work, but nevertheless, don't spend characters, precious screen space, 8025, to things that are redundant and can be easily discovered from using the IDE. Yeah, and so on, and so on. What's that? The core guidelines say avoid camel case. I say I'm not happy with all of the core guidelines. And depending on context, if I give examples to Java programmers, I use camel case. If I write code for the standard proposals, demo code, I use underscores. So I'm flexible about the camel case thing. Constants and immutability. There are 5 rules about constants, at least the last time I looked. It might have changed in between. Make objects immutable, make member functions const, pass pointers and reference to const. Use and make the const, use parameters const if you don't change them. And all pointer parameters should actually not only point to something const, but be const in the function so you don't do pointer arithmetic on them, like plus plus. And we have a tool doing that for you in many places. The guideline support library, what's in there, we have that owner, which is just a marker type. It's not really a type, it's still T star afterwards. We have not null, which actually tries to guarantee that a pointer is not null. And it tries to do something about that. So as a migration path, you can, if you expect the not null pointer, you can actually spell it out in the function signature, and the type will guarantee that it isn't passing in a null pointer. It will throw an exception if it might if it gets past the null pointer at runtime. There's one header called util. Whenever you call something util, it means, oh, I haven't figured out what a good name for it is. So whenever you have, well, util, tool, and generic names are very, very bad names. And we have scope guards in there by the name of finally. And I still hope to get something for C++ 20 out of the door. There's protection against narrowing errors with narrow. And we have things for like add for that work with plain arrays and containers and with bounds guard. And span and string span, there has some changes over time. They had a string view that was null terminated guaranteed, which the standard isn't. And I believe that's removed now from the core guideline support library. And just to show you what my students are working hard on, these are some of the rules that have been implemented. That's the screenshot from the version from last week. We have the, let's see, I don't believe that you can see the laser pointer on the video, but on the top over there we have the const checker that will actually provide you with adding the const to that. And then we have a group of students working on core guidelines, and you see they more or less work guideline by guideline, so the numbers come there. All the C things are about classes and constructors and special member functions in a class, like make swap no except, so they will mark code where swap is not no except, and if you write a no except false swap functions, you're cursed, and your code will not work well with the standard library. Or a non-swap, a no except false move operation is also not very nice. Things like conversions that are interesting using go-tos and do statements. The claim is about do statements, they are hard to read. And if you must use a cast, use a named cast, so no C-style casts. The bad thing about that is it's very hard to actually determine which cast you should use. So what this rule actually does, it provides you, and you can select if it's reinterpret, static, or const. And it will even give you a warning on reinterpret cast, I believe. At least that was one of the things. We have, even before the core guidelines, we cared about moving your code to C++ 11. So we have plugins for elevating your code or elevating your code and to replace C strings with std string and plain arrays with std arrays. We have some features for getting rid of macros. One thing is replacing function-like macros with const export functions. And the other thing is actually inlining the macro expansion if you don't get rid of that. And it also will detect, let's say, unused macros, so you can just eliminate them from your code base. A new thing I have for embedded developers is in embedded systems, you sometimes want to know how wide your integral variables are, like int 8t or unsigned 8t or unsigned 16t. And we provide now whenever you use an integral type that doesn't specify its size, you can actually refactor it to a corresponding fixed width size automatically. Yeah, I have one fan. And vice versa, which is also good, especially if the size is wrong or not appropriate for your new processor you're moving to. Yeah. Anything else try it. You all got your chocolate and your card to try it. And we might have a couple of minutes to actually see some of the examples. So I want to not only show you the slides, but actually some code. This is a class from my, sorry, I should go to the very top. So here we have a class with some special member functions and some data. And we get some markers over here. And one thing, let me show, okay, avoid redundant default operations, because the destructor is not doing anything, just being declared. Sorry, I don't know how to get rid of the hover. And we can either say set to default or set to no except. Let's first try set to no except. And we can still set it to default, and that's it. And what's that?
Or you could just delete it entirely.
You can delete it entirely, but the delete is not automatic. You have to select the line and press delete, which is also a single button. What else? The default constructor should be declared no except. So let's do it. Done. And value-like types should have a swap member function, because this no longer has a move constructor and a move assignment. So generated thing might be inefficient, but I don't show the quick fix for that because I haven't tried if it works. Well, I can be brave. Let's just try. Is there a quick fix? Define missing special member functions. Ta-da! Got it? What else? Add swap member function. And this is because we don't know what, especially it says, okay, please make it complete. And it might even tell me that I need a swap in the same namespace, and I'm not sure if that works. I should have saved explicitly. It comes. It has just had to rebuild the AST completely and wait for it to be done. In-class default initialized member variables. Ta-da. And now our default constructor, maybe. I stop with that. That's enough of the class. I don't want to make more interesting examples. And what have we here? Oh, we have interesting casts. So if you must use a cast, use a named cast. Control 1. Oops, that's the wrong focus. Now we have to make a choice. Use a static cast, is that right? Long to int? Good. And these are the test cases by my students with more interesting parentheses of casts. That's also something, oh, the go to end. Who was the go to end people? Go to exit, go to end? Yeah. Let's see, we have a go to end here, and we have a marker here. What does it tell us? Avoid go to. Normal if should work here. Let's see what we get. Change to normal if clause. Ta-da! No more go to end. But even the well, we have extract refactorings as well that might help to make the case that easy. And here we detect even that a break should actually work, and that's what it's done. And here we have a lossy conversion somewhere. Oh, the function is taking a float, and I pass in a double, which is a, and again, I changed the code so the index has to be rebuilt, or maybe, yeah, just takes a little. So I can use a narrow cast or narrow, and it will just enter the GSL part there. And it would also have added the GSL include if it was missing to the project. And this is bad code using character arrays, and that's one of the, I would say that's a canonical example of 80% of the security problems we have in the world. And we try to improve those by actually, refactor the C array and the std array. It actually should have been a string. Let me see what's going on here. Why isn't it? Oh yeah, it says do it a string. Come on. I thought I would get a string here. Yeah. Last time I got a string. I don't know why. That's when you show student code. And there's another canonical example. Oh, I have 100 bytes for my file name. It might work. Oh, I could add a const here, yes. And I can still refactor it. And it will even replace a string operation with the string operations in that case.
Remove the const.
And remove the const, but it's correct to remove the const because I changed the string.
Yeah.
It's no longer constable. If I, let's say, don't do that and save the code, it wouldn't be able to figure that out because that's also changing the code. And now you see a little C over there, and I can add the const qualification again. What's that?
Is there a reason that you do not refactor to the uniform initialization?
The reason is that the students didn't it that way at that time.
What kind of backend is required for this?
It's not a backend. It's all in the IDE. No backend. It's not using Clang Tidy or so. It's all in the IDE. Somehow I have some display problems because I changed the font size or whatever because it's.
If it's all in the IDE, couldn't we confuse it with templates?
What's that?
Could we confuse the parsing with templates if it's all in the IDE?
It's not too bad with templates because we also have a nice thing called the template visualization, which I don't show here, but which I showed last year, and you can have a video of that, and it's available, and you can try it. And if we find bugs, tell us, because we might be able to fix them. The template instantiation, to be honest, is working in many cases, but also not working in many cases. Because it's just, we have const extra evaluation and can do a lot of things, but they're always depending on the library you're using. For example, if you use libc++, it's much nicer because it uses fewer built-ins that we don't know what they do. GCC lib standard C++ is a little bit more involved, especially if you use an older version. It's very easy to get into situations where templates can no longer be instantiated correctly. Like one example is getting the reference type from a vector which goes through iterated traits and some built-in things, and then somehow is lost what the reference type is. And all because of vector bool. This is some real code, and just to show you a number of problems detected in one file. And we might, well, fish shell is actually a very, it's not what I intended. Now my font size is too big so that you can actually see something about it. But for example, we found C array, and that's something that should actually work, refactor to std array, and here we go, and it will all, and now it recognizes more things like, oh, it's uninitialized, replaced with uniform variable initialization, and I still can't get rid of that const qualification. And things like, oh, there's null here. And we might replace it with a null putter keyword for modernization. And this is something, here, don't use a variable for two unrelated purposes. So if you look here, we have size, which is size t, and using size of max arc, and then we have size somewhere else for something which is size t max arc, so no longer size of max arc. That's something interesting what's happening there. So that's something that you cannot actually automatically refactor because you don't know the purpose, but it will mark variables that are used for different purposes, which is most of the time just wrong. So anything else interesting to show? Uninitialized variable, or, oh, you see, we have pointers that aren't initialized. And things like that. So, wrapping up. Core guidelines, good thing, learn about them, follow them, use C-line or our tooling or Clang Tidy or whatever to clean up your code, check for violations and repair them. Take them with a grain of salt. There might be things that you don't agree with, and that's okay, unless I don't agree with you. And Visual Studio provides checkers as well. I forgot that. I'm running on a Mac and don't have a Windows installation handily available, so I didn't check what they actually do. I can speak with those guys next time in July and figure out where they can do much more than we do. And remember, no special member functions. Get rid of new and delete in your code bases, and write unit tests and use algorithms. And if you're doing Swift and want to do it on a non-Mac system, we are starting with a Swift IDE, or started, and it's available for download now, called Tiffic, which is a Swiss-German word for being Swift. And just as of today, and it's not fake, it's copied from GitHub, we got a error, a bug, but in the bug we got that praise, and I'm very happy that we have actual users who like our stuff. And I hope I get more users now. It's free. And if you want to spend money and want commercial licensing, we are open to discuss that. Because as a university, we're always short of money. And in Switzerland, everything is expensive, especially the salaries of my employees and mine as well. And fortunately, the snow is gone, but that's our campus. So when you intend to come to the C++ Standardization Committee next year in June, that's where we will meet. And it's 30 seconds from lecturing to swimming in the lake in summer. Maybe June is a little bit chilly, but you might use a rowing boat or whatever you can do.